Chapter 6.1 Rational Expressions. If a of x and b of x are polynomials, then a of x divided by b of x is a rational expression if b of x is not equal to 0. The values that make the denominator of a rational expression equal to 0 are known as non-permissible values. To find Npvs, non-permissible values, we need to make sure the denominator is factored. Let's look at these three examples and find the non-permissible values for them. 4a over 3bc, the denominator cannot equal to 0. So what values of b would make the denominator equal to 0? Well, it's 3 times b times c. So if we have a 0 as either of our b or c values, then the denominator would be 0. 3 times 0 times a number equals to 0. So we would say b cannot equal to 0 and c cannot equal to 0. We could also write this, so you can write not equal to, or you can write Npvs are b equals 0 and c equals 0. So either way, it doesn't really matter to me if you write the equals or the not equals to, as long as you're identifying that they are your Npvs. Next one, x minus 1 divided by x squared minus x minus 6. We need to factor the trinomial on the bottom. We want two numbers that multiply to negative 6 and add to negative 1. They're one negative and one positive because they multiply to a negative and then they add to a negative, so the negative 1 would have to be bigger. So negative 3 positive 2 multiplies to negative 6, negative 3 positive 2 adds to negative 1. Factored form then becomes x minus 1 over x minus 3, x plus 2. We can't have our denominator equal to 0. What would make the denominator equal to 0? If either of our factors was equal to 0, because then we'd have 0 times some other number would be 0. So x minus 3 can't equal 0, which means that x can't equal 3. And x plus 2 can't equal to 0, which means that x can't equal to negative 2. And again, you could also just write that as your Npvs are the values x equals to 3 and x equals to negative 2. Next example, 2y squared over y squared minus 4. We have to factor this. This is a difference of squares. When we factor a difference of squares, we square root the first term, y squared, square rooted is y. That goes at the beginning of each bracket. We square root the last term, square root of 4 is 2. And then we put one with a plus and one with a minus. Then we can't have either of these factors equal to 0. Y plus 2 can't equal to 0, so y can't equal to negative 2, and y minus 2 can't equal to 0, y can't equal to 2. And again, you could also write this as your Npvs are the values y equals, and we could write plus n minus 2 so that we're just writing it once, or you can write it as plus 2 minus 2. Simplifying rational expressions. Step 1, we need to factor the numerator and denominator if possible. Step 2, state the Npvs. And step 3, reduce the fraction. Simplify and state the Npvs for the following rational expression. So step 1, we want to factor the numerator and the denominator. our numerator, 2y squared plus y minus 10. There's no common factor. 2, 1, and negative 10 don't have a common factor. So this is a complex trinomial. We need to multiply the a value times the c value. 2 times negative 10 is negative 20. We're looking for two numbers that multiply to negative 20, and they still add to the b value, which in this case is 1. That tells us that the numbers are 1 off from each other. They might be one positive, one negative, but they're 1 away. So negative 20, if we had 5 and negative 4, that would multiply to negative 20, and 5 plus negative 4 would add to 1. Those are our numbers. Now we need to use box method or decomposition. I'm going to use box method. Top left box is 2y squared, bottom right box negative 10. The other two boxes are 5y and negative 4y in either order. Common factor each row and column. 2y squared, 5y is just y. Negative 4y, negative 10. There's a negative at the beginning of my row, so my common factor, no matter what, is going to be negative. It'd be negative 2. First column, 2y squared and negative 4y is 2y. And then the second column, 5y and negative 10 is 5. Notice for the columns, the common factor is not negative. That's because the negatives in each column is at the bottom of the column. It needs to be at the top of the column if my common factor would be negative. So we get the numerator factors to y minus 2, 2y plus 5. We need to factor our denominator. It's a basic trinomial, y squared plus 3y minus 10. So we want two numbers that multiply to give us the c value, which is negative 10, and add to the b value, which is 3. They would have to be opposite signs, and the positive one would have to be bigger. So 5, negative 2, 5, negative 2. It factors to y plus 5, y minus 2. So we have it factored. Next step is to state our Npvs. Looking at the denominator, we have y plus 5 and y minus 2. We need to figure out what values of y would make those equal to 0, and then those values would be our Npvs. Y plus 5 equals to 0 when y equals negative 5, and y minus 2 equals to 0 when y equals 2. So our Npvs are negative 5 and 2. Step 3, we can reduce our fraction. Writing my factored form again, I had y minus 2 times 2y plus 5 over y plus 5 times y minus 2. So what common factors do I have in the top and bottom? I have y minus 2, y minus 2. So I can divide the y minus 2's, they divide to 1. I'm left with the reduced rational expression 2y plus 5 over y plus 5. Next one. First step is factoring. We can factor out a common factor of 2 from the top. We get 2 times 3 minus m. On the bottom, it's a difference of squares, so we can factor it to square root of the first term at the beginning of both factors, square root of the last term, which is 3, 1 plus, 1 minus. Now we have it factored. Step 2 is our Npvs. We want to know when the bottom factors are equal to 0. M plus 3 equals 0 when m equals negative 3. m minus 3 equals 0 when m equals to 3. So our Npvs are negative 3 and 3. Step 3, reduce our factored form to 3 minus m over m plus 3, m minus 3. Looking at my factors, 3 minus m and m minus 3 are not the same because subtraction is not commutative, so the order of subtraction matters. So if I want to switch the order of a negative factor, so instead of 3 minus m, I want m minus 3, I can do that by factoring out a negative. So if I factor out a negative, I get negative 2 bracket negative 3 plus m, because it changes the sign of each of our factors, over m plus 3, m minus 3. Then we can change the order of our factor. We get negative 2 bracket, we have positive m minus 3 over m plus 3, m minus 3, and then we divide out our common factor of m minus 3, and we're left with negative 2 over m plus 3. Simplify and state the Npvs for 16x squared minus 9y squared over 8x minus 6y. Same process. Step number 1, factor. 16x squared minus 9y squared. I don't have any common factor there, but if you look at the numbers, 16 and 9 are perfect squares, perfect square numbers. X squared and y squared are perfect squares, and then we have a minus, so it's a difference of squares, which would factor to square root of the first term is 4x. Square root of the last term is 3y. One with a plus, one with a minus. The denominator, 8x minus 6y, I can factor out a common factor of 2. I get 2, 4x minus 3y. Step number 2 is to do our Npvs. This one's a little bit different because we have two variables. So 2 is 2, it can't equal 0, but this factor we have, 4x minus 3y, could equal 0. So that's what we're looking at, 4x minus 3y. We want to know, when is that equal to 0? We have two variables, so we're going to solve for both. We're going to do this twice. So let's say that we start by looking for the x value. We're going to add 3y to both sides. We get 4x equals 3y. Divide by 4, divide by 4. We get x is equal to 3 over 4y. And then if we solve for y value instead, 4x minus 3y equals 0. We're going to, again, add 3y. Then we have 4x equals 3y. Now instead of dividing by 4, we're going to divide by 3 to get the y by itself. And we have y equals 4 over 3x. So those are our Npvs, 3 over 4y and 4 over 3x. Step 3, reduce our factored form, 4x plus 3y times 4x minus 3y over 2 times 4x minus 3y. We can divide out the common factors of 4x minus 3y. We are left with 4x plus 3y divided by 2. What is the Npv for x when y is equal to 3? So we said our x Npv, x equals 3 over 4y. That's our Npv. So when y is equal to 3, let's just sub in 3. X equals 3 over 4 times 3, which is 9/4 or 2.25. Last question, evaluate the expression for x equals to 1.5 and y equals to 2.8. So we could evaluate the expression that's saying plug in the values for x and y and calculate what it equals. Now we should use the original function because we don't know the exact values of our Npvs. So we don't actually know if 1.5 and 2.8 might be Npvs, okay? Normally, like up here, we have an exact value for our Npvs. So if it told us to plug in m equals to 3 and solve, we would know that we can't do that value. But down here, because we have these strange Npvs where the Npv depends on what the values are, we don't actually know. So we should plug it into the original, and that way if it is an Npv, we'll end up having to divide by 0, so we'll figure out that we can't do it. Whereas if we plugged it into this one, we've taken out that denominator that has the x and y. So no, even if we plug it in Npv, we would get a real answer. Okay, so we're going to plug it into our original function there, 16x squared minus 9y squared divided by 8x minus 6y. So plugging it in, we have 16 times 1.5 squared minus 9 times 2.8 squared divided by 8 times 1.5 minus 6 times 2.8. And then we're going to calculate. Brackets for my numerator, bracket 16 times 1.5 squared minus 9 times 2.8 squared, close brackets for the numerator, divide, open brackets for the denominator, 8 times 1.5 minus 6 times 2.8, close bracket for the denominator, and we get 7.2. That brings us to the end of the first lesson for Chapter 6.